Okay, in Concept B, we're going to be focusing on the subatomic particles, which you know as protons, neutrons, and electrons. So students, you should be able to have a basic understanding by the end of this video on how to identify the subatomic particles of an atom, be able to describe their properties, including location, charge, and mass, and be able to calculate or determine the number of protons, neutrons, and electrons based on what is called the atomic number and mass number. So let's just talk about these subatomic particles, the protons, neutrons, and electrons, which you probably have a good idea of already from middle school and other science classes you've taken so far. So the proton has a charge of +1, so has a positive charge. We say that it has a mass of 1 atomic mass unit. It's located in the nucleus, and how to calculate it is by looking at the atomic number. You'll find in your reference table we can represent a proton with one of these two symbols. A neutron is neutral, that's why I put it as 0, but you can feel free to write neutral there. It also has a mass of 1 atomic mass unit and is also located in the nucleus. That's why we can say the nucleus has most of the mass of the atom. We can determine the number of neutrons by taking our mass number and subtracting out the atomic number. And again, this is a common symbol for a neutron. And then finally our electron, this has a negative charge, has a very tiny mass, only 1 over 1,836 atomic mass units. So it doesn't contribute too much to the mass of an atom because of the protons and neutrons being so much greater in mass. Our electrons are located outside the nucleus in what is called an orbital, and we can find the number of protons in a neutral atom by making them equal to the number of protons, because our positive charges are going to be equal to our negative charges in order to be neutral. And this is a very common symbol showing a little letter E and a -1 in order to represent the negative charge. Now, the atomic mass unit that I've been mentioning is defined as the mass of exactly equal to 1/12 the mass of a carbon-12 atom. This means that the mass of one carbon-12 atom is assigned to be exactly 12 AMU. So just kind of keep that in mind whenever you see a type of question that talks about what an atomic mass unit is based off of. Think about carbon-12 atoms, and then we're taking 1/12 of them in order to define this mass unit. So a little bit more about the structure of the atom and its subatomic particles. Within the nucleus, this contains most of the mass because it's made up of those protons and neutrons. Also, it has a nuclear charge, and this is based on those positive protons because the neutrons or neutral don't contribute to the nuclear charge. Outside the nucleus, this is where the electrons are located, specifically in orbitals. And we have talked about earlier in Concept A, the electron clouds and how they're arranged outside the nucleus. Now, you can represent atoms by the following notations. I just like to point these out because you're going to start to see them throughout the next couple of concepts. We can generally show our symbol with the mass number in the upper left-hand corner and then the atomic number below it. Most of the time we don't even bother to show the atomic number just because we can always find that on the periodic table. We can also do the symbol dash the atomic mass or the element's name dash the atomic mass. Again, these numbers are always going to be representing the atomic mass because by using the symbol we can look up the atomic number, which we're going to talk about in just a second. So every atom is defined and identified by its number of protons, and this is the atomic number. So if an atomic number is 8, it has to be oxygen, because all oxygens have an atomic number of 8 because they all have 8 protons. Every atom of krypton must have 36 protons, which is also its atomic number, because every atom has to have those 36 protons. 36 is its atomic number and identifies it. So all protons can be determined by looking up the atomic number of an element. Now the mass number is the number of protons plus the number of neutrons. Now something will come up later on called atomic mass. This is not the same thing. So mass number is a very specific whole number and it represents the number of protons and the number of neutrons. Neutrons are in the nucleus and they have mass but do not change the identity of the atom. Protons and neutrons don't have to be equal. A lot of the elements that we deal with that have an atomic number 20 or under tend to be relatively the same amount. However, as you get to larger elements, you're going to see that protons and neutrons definitely are not equal. So just kind of keep that in mind because a lot of students make that, it's a common misconception. So because we can find the number of protons using the atomic number, I can really use the mass number to determine the number of neutrons. So the number of neutrons is the mass number minus the number of protons. Now the term atom is used only when it's neutral. This is a common misconception of students when they read questions, especially old chemistry regents questions, when they throw in the term atom. They're telling you it's neutral when they say it's an atom. So this means that atoms must have an equal number of positively charged protons and negatively charged electrons. Our positives and negatives have to equal each other. Based off of that, the number of electrons in an atom has to be equal to the number of protons, which is also equal to the atomic number, which is a useful piece of information. So how many protons, neutrons, and electrons are in a neutral uranium atom with a mass number of 238? So from the periodic table, we can use the fact that we have a uranium atom to get an atomic number of 92, and from the problem, it gives us the mass number of 238. So we can use these two numbers to determine the protons, neutrons, and electrons. Well, since our atomic number equals our number of protons, our protons have to be 92. Our number of neutrons, remember, is our mass number minus our atomic number, so we have 146 neutrons. And then in our neutral atom, our protons must be equal to our electrons, so the electrons are also equal to 92. Finally, you should also be able to think about the nuclear charge. Since our nuclear charge is equal to the number of positively charged protons, we have a nuclear charge of positive 92. Alright, so you're going to go ahead and fill in this chart. I would pause it, go back to the example and some of those box information in your notes to kind of jump around to each thing, and then I'll give you all the examples. Alright, so this first one, which had 12 neutrons and an atomic number of 11, I was able to figure out, based on these two pieces of information, especially the atomic number, that if my atomic number was 11, it had to be sodium, and also my protons had to be 11. And because protons and electrons are equal in an atom, if my protons are 11, my electrons are also 11. My mass number was found by adding our protons and neutrons, which was 23. Our nuclear charge is always equal to the number of protons, so that was positive 11. And then symbols, this is one way that you could represent sodium with a mass of 23. All right, our next example that had 14 protons, by looking that up on the periodic table, I could figure out that I have silicon, and I also have the number of electrons is 14, my atomic number is 14, and my nuclear charge is positive 14. Because my mass is 28, 28 minus 14 gives me 14 neutrons. And then here's another way to represent silicon by showing the atomic mass of 28. Alright, next I have the number of electrons is 13 and my mass number of 27. Because this is an atom, my number of electrons also represents my number of protons, which is 13, which gives me the fact that I have the element aluminum. I can figure out using my mass number minus my protons to get 14 to get my number of neutrons. My nuclear charge is equal to my number of protons, and then I can show aluminum 28 in this symbolic form. And then finally I have chromium. By using the atomic number, I can get my protons and electrons and nuclear charge, and then I can get my mass number by adding my protons and neutrons to get 55. Again, here's a way to represent chromium 55. Okay, well, we're going to do a lot of practice of this in class tomorrow. Just get the basic idea of how to figure out and determine those number of protons, neutrons, electrons, and also review the whole structure of the atom so that you feel comfortable with that before class tomorrow.